All right, Team Impact, we're moving on today to lesson 2. We're in the note-taking guide here. To get started here, we're going to talk about equivalent fractions here, and let's get into it. So yesterday we were talking about just writing and simplifying fractions. If we go to lesson 2, it looks like this, all right? Equivalent fractions and comparing and ordering, okay? All right, so let's get started here, all right? So when we write equivalent fractions, we want to be able to scale up or scale down, meaning that we're going to multiply the numerator and the denominator by the same number, right? So if we look at this, 1/2 is equal to 2/4, which is equal to 4/8. So they multiplied both of those by 2, and then again, they multiplied both of those by 2. We call that scaling up, right? So if we wanted to scale this 3/4 up, I would multiply both of those by 2, or 3, or 10, or 1,000,000, right? And I would end up with 6/8. If I did it again, I could go 12/16. So we're just scaling those up. And sometimes we're going to scale down when we have to simplify, which is what we did yesterday, right? Okay, so give two equivalent fractions for each of these, right? So again, I can multiply both of these by 10. 4 times 10 is 40. 5 times 10 is 50. That's one. I can multiply both of those by 2 and get 8/10. So they're both equal. So whatever you want to do there is fine, right? Here, times 2 times 2 times 3 is 33 times 3 is 36. So I've multiplied them both by 2 here and both by 3 there. Over here, same thing. It's just an improper fraction. We're just scaling it up again, right? So we could go times 3 right out of the gate. 14 times 3 is 42, and 9 times 3 is 27. So you're getting the idea about scaling, right? If I multiplied them both by 5, right? 14 times 5 is, what is that? It's 70. And 9 times 5 is 45. So that, and that are all equal or congruent, right? Okay, so let's move on here. Next piece, right? They're giving us a fraction, 1/2, and they're scaling one number up. In this case, it was the denominator. So this was times 3. That's times 3. This is just mental math facts, right? This was divided by 5, so we're going to divide that by 5, and we're going to end up with 3/4. This was divided by 2, and this was divided by 2, right? So we're going to end up with 8/9. So just mental math. What times 9 is 18. We're just working backwards. There's other ways to do it, but right now when the fractions are simple like this, all right, we can just do it mentally. Let's finish out. Times 4, or divided by 4, right, is 10, right? Times 8 is 16. So we multiplied both of those by 8. Times 6 is 18, right? So those math facts really help us there. Now, next piece up. Are the fractions equal? Well, there's a couple different ways to do this, and I'm going to show you both, and you decide whatever way you want to do. This is fine. We can kind of look at it and kind of reduce it, right? So I can take this down, divide it both by 2 from our mental math divisibility rules. That's 2/3. Divide both of these by what here? Looks like 4 goes into both of those, and I could see that they are equal. So yes, they're equal. All right. But there's an easier way to see if they're equal. We can cross multiply, right? And what I mean is, I could see that what 1 times 20 is, and I write that above the numerator that I used. 1 times 20 is 20, and 4 times 4 is 16, right? 20 and 16 are not equal, so that is a no, right? Okay, so when the fractions are manageable, I like to do this. When they're a little bit bigger, sometimes I like to reduce. So both ways are very convenient for us, right? So let's take a peek at this. All right. So this I don't really want to multiply 16 and 6 and 15 and 5 and 18 because that's not mental math for me. So I'm going to go ahead and reduce this. So I'm going to divide both of these by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. I'm going to divide both of those by 6, right? 6 divided by 6 is 1. 18 divided by 6 is 3. So they are equal, and that's a yes, right? So, all right, when they're bigger, it's a little bit easier, all right, to do it, just simplifying. Let's continue on here. We'll do one more of these, and then we'll kind of get out of this because they're getting a little bit too big. And if they get too big, again, I would use a calculator. But let's take a look at this. Both of these are divisible by 7. 21 divided by 7 is 3. 14 divided by 7 is 2. What will go into both 27 and 18? Well, both of those are divisible by 9. We can get the bigger the better, right? 27 divided by 9 is 3. 18 divided by 9 is 2. They are equal, so it is a yes. Okay? So you're kind of getting the idea there, right, of that. All right? And I'm going to skip these next two because of time purposes for this morning here, okay? Okay, let's continue on. Now, when we go to the next page, okay, we're going to talk about unlike fractions here. And unlike fractions are simply fractions with different denominators. Right? So an example would be 7/11 and 1/3. They're different denominators, so they're unlike fractions. Unlike fractions, okay? Okay, so let's slide down here to number 16. Let's skip this, save a little bit of time. All right, and let's talk about 16. We want to do a less than, a greater than, or an equal to. All right, so this is definitely where I'm going to go ahead and cross multiply, right? And whatever number is on the top is greater, okay? So 7 times 1 is 7. And you notice I write it on the side, I use the numerator for. 3 times 3 is 9, right? So 9 is greater than 7, so I know that 3/7 is greater than 1/3, right? Now there's another way to do it. We could get a common denominator, which is a little bit more work, and I'll show you how to do that on number 17. I know that 5 goes into 15, so I could rewrite this fraction with 15 on the bottom times 3 is 12/15. Since I have the same denominator, I can compare my numerators. 12 is less than 13, so therefore I need a less than sign. So there's a couple different ways to do it. I like the cross multiplying. It's just a little bit quicker for me, all right? And it helps me, all right? All right, so let's go on here. 10 times 6 is 60. 4 times 15 is 60, right? So 15 times 4 was 60, 6 times 10 was 60. Those two fractions are equal, right? So most people like this technique better, right? But when the fractions get bigger like this and I can't multiply those mentally, sometimes I need to scale it up. I clearly see that 6 will go into 24. So I'm going to rewrite this fraction with a denominator of 24. Okay? 6 times 4 is 24, 5 times 4 is 20. I have the same denominators, right? So now I compare my numerators, and I'm going to rewrite this fraction underneath so you can see it a little bit better. 20 is less than 23, so 5/6 is less than 23 out of 24. And if you think about this, 23 out of 24 is almost one whole because 24 out of 24 is one whole. Okay? Okay. So let's continue on, all right? I'm going to cross multiply these because I have a 10 there. 7 times 10 is 70. And I might have to come off to the side and do this work, right? 4 times 7 is 28, and that's 68, right? So 70 is greater than 68, and 7/4 is greater than 17/10. So what works for you, right? Okay. Let's continue on and take a peek here. We're going to cross multiply here because I know that 10 times 12 is 120. That's an easy one. But 15 times 8, 8 fives are 40, carry the 4, it's 120. Oh, guess what? They are equal. That's nice. So being eclectic, having a couple different ways to look at it is a good thing, okay? All right, so let's pause there for a second and let you kind of get caught up. We're rolling right along here. And let's get in down here to ordering fractions from least to greatest and greatest to least. Now, when we order fractions, we're unfortunately going to have to write all of these with a common denominator, right? And we're looking for the least common multiple of these three numbers, okay? I know that 5 goes into 20 and 2 goes into 20, so I'm going to rewrite all of these with a denominator of 20, right? So that already has 20, so I'm going to rewrite it, and I'm going to draw a line to separate it. 5 times 4 is 20. All right, 4 times 2 is 8. I'm going to separate that. 2 times 10 is 20, and 1 times 10 is 10. Now, we're going to go least to greatest, the smallest number here. All right, the smallest fraction here. Now, when we have the same denominators, we're just looking at the numerators. The smallest one here is 7/20ths, so I'm going to rewrite it. The next smallest one is 8/20ths, but I want to rewrite the original value of 2/5. And then finally, we have 1/2, right? 1/2. Okay. All right, let's do one more of those. I clearly can see that 9 goes into 18 and 3 goes into 18, so I'm going to rewrite all of those with a common denominator of 18. 3 times 6 is 18. 6 times 2 is 12. 9 times 2 is 18. 5 times 2 is 10. We have the same denominators there, right? So now we just compare the numerators. The smallest one is 10/18. The original value was 5/9. Okay? The next smallest one is 11/18, and the original value was actually 11/18. So we've taken care of those, and then finally we end up with 2/3, right? All right. Another way to go ahead and compare those is changing them to a decimal. That works as well, okay? All right. So that's today's lesson. We're going to skip these two because I'm running out of time here this morning. But let's go into the homework packet and see what we have here for lesson 2. Okay, so lesson 2, okay, we have numbers 1 through 20, right? 1 through 20, all right? And I may do a couple of these with you in class to kind of get you rolling with that. But that is due tomorrow, which is Friday, October 3rd, along with Khan Academy. All right, guys, have a great day. I'll see you in class, hopefully. Bye-bye.